Exercise 9.4, question number 11. Limit x tends to 0, root of x square plus a square minus a divided by root of x square plus b square minus b. We know the formula. Limit x tends to a, x power n minus a power n by x minus a is n into a power n minus 1. So you know that x power n minus a power n, the same term x and this term a should be there in the denominator, and also x tends to a should also be there. Only then we can apply this limit formula. So we can write this as limit x tends to 0. So we can write it as x square plus a square to the power half minus a, you can write it as a square to the power half. The same way, the denominator x square plus b square the whole power half minus b square the whole power half. X tends to 0. Now this is equal to limit x tends to 0, x square plus a square the whole power half minus a square the whole power half. Now you should have the same term. See, if it is x power n minus a power n, you should have x minus a. This term x and this a should be there. So that means this x square, this term x square plus a square minus a square should be there in the denominator. That is not there. So multiply and divide by this term. So same term you multiply and also divide. The same way the denominator. Now the denominator you can split the limits. You know that limit x tends to a, f of x by g of x is limit x tends to a, f of x divided by limit x tends to a, g of x. You can split the limits like this. So this limit you can put for the denominator also. So limit x tends to 0, x square plus b square the whole power half minus b square the whole power half divided by, same term should be there, x minus a should be there. That means this term x square plus b square minus b square should be there in the denominator. So x square plus b square minus b square should be there in the denominator. It is not there. So you divide and multiply by the same term x square plus b square minus b square. So we have brought it in this form, x power n minus a power n by x minus a. But what about the limit? Limit x tends to a should be there. But here we have limit x tends to 0. But we can change this. That is, when x tends to 0, you know x square tends to 0. Add a square on both the sides. So we can write this as limit x square plus a square tends to a square, and the numerator is x square plus a square the whole power half minus a square the whole power half divided by x square plus a square minus a square, and here you have x square plus a square minus a square. The same way the denominator, limit x square plus b square tends to b square, then you write x square plus b square the whole power half minus b square the whole power half divided by x square plus b square minus b square, the same term you have to multiply and divide. Now we can use the formula limit x tends to a, x power n minus a power n by x minus a is n into a power n minus 1, n into a power n minus 1. So this term is this term. When you apply the limit formula, n is half into a. In the place of a, you have a square. So a square, the whole power, half minus 1. The same way the denominator, if you apply the limit formula for the denominator, you get n. n is half b square, the whole power, that a power n, the b square, this b square, half minus 1. And here a square get cancelled, plus a square and minus a square get cancelled, plus b square and minus b square get cancelled, and you are left with x square here and x square here. You can cancel this x square and also this x square. So you have this now, cancel this half and half. So you get a square to the power half minus 1 is minus half, divided by b square to the power half minus 1 is minus half. So this is 2 cancel, 2 and 2 get cancelled. So you get a to the power minus 1, b to the power minus 1. So when there is nothing but a by b, the whole power minus 1. When the exponent is negative, take the reciprocal. So that is b by a. So that's the answer, b by a. 12th one, limit x tends to 0 to arc sin x by 3x. Arc sin x is a new term. This is nothing but sine inverse x. So here 2 by 3 is a constant. You can take it outside the limit. So limit x tends to 0. Arc sin x is sine inverse x by x. So that is equal to 2 by 3. So the limit formula, limit x tends to 0, sine inverse x by x is 1. So the answer is 2 by 3. Question number 13. Limit x tends to 0, 1 minus cos x by x square. Now in all these problems, if you see, when you apply the limit straight away, if you apply put x is 0, you get root of a square is a minus a, that is 0. Here when you put x is 0, root of b square minus b, that is b minus b, that is also 0. This is indeterminate form. So we apply this method to find the limit. The same way even here, if you apply the limit straight away, you get 0 by 0. Sine inverse 0 by 0. It is 0 by 0, indeterminate form. So we apply the formula limit x tends to 0, sine inverse x by x. That is x tends to 0. When x is 0, it is 0 by 0, indeterminate form. But when x tends to 0, it is 1. Limit x tends to 0, sine inverse x by x is 1. The same way, if you apply the limit straight away, you get 1 minus cos 0 by 0. That is 1 minus 1, 0 by 0. That is indeterminate form. Cos 0 is 1. So 1 minus 1, 0. So now let us use the trigonometric formula. 1 minus cos x is 2 sine square x by 2. So limit x tends to 0. 1 minus cos x is 2 sine square x by 2 divided by x square. This 2 is a constant. You can take it out. So 2 into limit x tends to 0. Sine, this is x by 2 divided by x. the whole square. So we know that limit x tends to 0, sine x by x is 1. So if I have x here, you should have x here also. So if it is x by 2, I should have x by 2 here. So divide by 2, because I need x by 2. When you divide by 2, I should also multiply by 2. Now this is a constant, 2 square. There is a square outside. The 2 square take outside the limit. So that is 2 by 4. Limit when x tends to 0, x by 2 also will tend to 0. So x by 2 tends to 0. Sine x by 2 by x by 2. You can write it as the whole power 2. So we know that x tends to a, f of x, the whole power n. You can write it as limit x tends to a, f of x, the whole power n. Both are same. So this is equal to 1. This term, this is 1 by 2, limit x by 2 tends to 0, sine x by 2 by x by 2, the whole square. This power you can put it outside the limit. Now this is 1. This value is 1. From this formula it is 1. So that is 1 by 2 into 1. It is 1 by 2. That is the answer. 14th question. Limit x tends to 0, tan 2x by x. Limit x tends to 0, tan x by x is equal to 1. So here, if you have 2x, you should have 2x here. So multiply and divide by 2. Divide by 2, multiply. That multiplied by 2 you can write outside the limit because it is a constant. So this is 2 into limit x tends to 0. You know that 2x will tend to 0. So 2x tends to 0, tan 2x by 2x. So that is equal to 2 into 1. It is equal to 2. So that's the answer. Now the next one. Question number 15. Limit x tends to 0, 2 power x minus 3 power x by x. So we are going to use the limit formula. Limit x tends to 0, a power x minus 1 by x is log a. A power x minus 1 by x is log a. So that 1 is missing here. 2 power x minus 1. So let us add and subtract minus 1. So 2 power x minus 1 minus 3 power x plus 1. We have subtracted and added minus 1 plus 1. We have added and subtracted 1 divided by x. So that is equal to limit x tends to 0. You can split this 2 power x minus 1 by x minus 3 power x minus 1 by x. When you take the minus sign outside, it will become 3 power x minus 1. Minus into minus plus here. So now we can split the limit. Limit x tends to 0, 2 power x minus 1 by x minus limit x tends to 0, 3 power x minus 1 by x. So it is log a. So the a is that constant. So here a is 2. So this will become log 2 minus log 3. Okay. Even here when you apply the limit straight away, 2 power 0 minus 3 power 0, 0 by 0, it is indeterminate form. So log 2, so because it is indeterminate form, we are using the formula and doing. So log 2 minus log 3, you know the log quotient rule. Log A minus log B is log A by B. So this is equal to log 2 by 3. That's the answer. Thank you.